In this tutorial, I'll show you how you can use Google Sheets, which is an online program that doesn't cost anything, to process your data and create a scatter plot and insert a trend line into that scatter plot. So let's get started. First of all, you're going to have to open your web browser. I'm using Safari here. Got that open. And we're going to go to, actually, here at Google, that'll be just fine. You can either go to Google Drive or Google Sheets, or just go to Google and log into Google. Now, if you don't have a Google account, you'll have to make one. You can add an account, and under Add Account, it'll give you the option to create an account. Simply follow the instructions, and you just need a Google account. It doesn't cost anything, like I said. I'm going to go ahead and log in. And here I'm at Google. Now, from Google, I want to go to the Google Drive or Google Sheets. So I'm going to type in sheets.google.com. Sheets is the spreadsheets program. Let that load. Okay, so we're in Google Sheets. You don't need to download any program. It's all online and it works through your web browser. Now we need to upload our data. So what I'm going to do is go into this little folder, which allows me to select a file that I would like to use, and I want to upload a new file. I'm going to go to Upload. Now I can either drag the file to this big box or select it from my computer. I happen to have it right here on my desktop, so I'm just going to do the drag and drop and let that upload. This is the file that I'll have sent you in an email. Okay, so this is our data from the experiment. We have the different concentrations of salt solution and your initial mass and final mass that you measured in grams. So first of all, we need to calculate the percentage change in the mass, and this works really identically to Excel, so if you know how to do that, you're well set up. I can either type the equation right into this cell, or I can select that cell and use the equation bar. I like to use it right in the cell, so I'm going to say that the change in percentage of mass is equal to, that tells it that it's an equation I need it to calculate. I'm going to open a parentheses and say it's difference between C3 and B3. Oops, got ahead of myself. C3, so C3 minus B3, that's the difference, right? Divided by the initial. That's the equation for percentage change mass. This is the change in mass, and if you divide it by the initial mass, then you get the change in mass in percent. And that calculates that. Now I don't have to type that in every time, as you know. I can do Control Copy or Apple Copy and paste that into each of the places that I need it. It's good to do a double check on which values it's using to calculate that. I'm now at C4 and B4, that looks right. I'm going to head down here and do the same thing. Paste, 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 paste. These values look like they make sense. Losing more and more mass as I go into the higher and higher concentrations. All right, this is about 8%. But that's not all. I also need to make an average. I'm going to call this average change of mass. I'm just going to select the lower of these two cells is equal to average, open parentheses, and then I just need to tell it which two values, value 1, comma, value 2. So I want an average of D3 and D4, close parentheses, enter. Okay, this is my average. Now again, I'm going to do a copy and paste. And I want to make sure that this is referencing D8 and 9, which it is. And then I can carry on and do that. If you ever have a problem where it says ref or you put in an equation and it just really doesn't make sense. That's always the first thing to check. Which cells is it referencing, and is it referencing the correct cells? So those are my average data points for the change in mass. But I don't want to present it this way. I'd like to clean this up and present it in a summary table. So I'm just going to go over here and make my pretty table that I can put in my analysis section of my paper. On the one side, I have the concentration of the salt solution. And then I need to open the parentheses, plus or minus 0.01 molar. So this is really important when you're presenting scientific results, that you first of all give the measurement uncertainty as well as the units. Otherwise, it's just a list of numbers that doesn't mean anything, right? Now I'm going to make this column a little wider so that everything fits in there, and the other information is the average change in mass, and all of that's going to be plus or minus 0.1, and this is percent, right? Close parentheses on that. So I'm also going to make that column wide enough for my title. These ones were easy. This was 0, 0.1, and I can have Google Sheets extend that out for me to 0.5. And these are the values that I just calculated, right? So what I'm going to do here, what I could do is I could copy and paste the values into here. What I'm going to do is I'm going to link these cells, which means I'm going to just put an equal sign in here and tell Google Sheets this cell is equal to this cell. So is equal to E4. And then just whatever value is in this cell, it presents in this cell as well. And do that for each of these. So that, and I'll show you why that makes sense later. Basically, if I end up changing any data points or I get new data and I add to that, I don't need to go back and recopy everything. So for 0.3, okay, so I've got my values copied into here, well, linked into here, but these still aren't presented as percentages, so let's go ahead and do that. I want to go up then to the Format menu after I've selected my data, Format, Number, and I want these to be percent. So here we go. Those are my percentages. Those are my concentrations. This is my summary table. Now I want to go ahead and graph this data as well. So I'm going to select that data, my summary table, and I can either go Insert and go down to Chart, or I can just go right on this little bar if you know that that icon means Insert Chart. Insert Chart. Now it's asking for what kind of chart, and bar charts are kind of the most common ones, so it recommends those, but I want a scatter chart. I'm going to go over to the different chart types. I want to grab this little scroll bar and head down to Scatter. Okay, so it's showing my concentration of salt solution in the y-axis, which is what I want, and the molarity of, that's the percentage. We'll have to fix that as we go along. That's not the right label for that axis. So good things to pay attention to, which means we need to go over to this customization. These are all the options that I can change in my chart. I can go and do that right now. The title is not concentration of salt solution, but the title is change in mass of potato. I always put the E on there without E. Potato tissue in different concentrations of salt solution. That's the title. I want to put the legend. I'm just going to put down at the bottom for now. I'm fine with the font. Okay, here's my axes. For the horizontal axis, this is the concentration of salt solution. And don't forget, I need to add the measurement uncertainty. That's plus or minus 0.01 molar, as well as the units molar. That looks, let's see if that shows up. Concentration of salt solution plus or minus 0.1 molar, which is what is presented on that axis. And then to do the vertical axis, left vertical, this is the change in mass of potato tissue. And once again, with measurement uncertainty, 0.1% and units percent. Okay, let's see if that fixed that. That's what I need there. And then keep scrolling down all these options. Here I can change what my minimum and maximum are of each axis. For example, I want this to be my last data point. I don't want it to go all the way up to 0.6. So first of all, I need to select the horizontal axis. And I'm fine with the minimum. I want the maximum to be 0.5. Enter, and then it shows me what that will look like. So I'm going to just keep scrolling down here and look at all the different options that I have. The series is just the data series. We only have one data series, so we can leave that. I can change how it looks, the color, what type of points those are all fine. And down at the very bottom, you see trend line, and I want to add a trend line. Obviously, a linear trend line. Some data is exponential or polynomial, but ours should be linear, which is a linear trend line. And for the label, I want the label to use the equation, and this will show us what the equation is for our line, which is going to be important, of course, to calculate the osmolarity in the end. And that shows it right up on my graph. Okay, so insert. Those are all the things I wanted to change on here. Now I have my graph. Now you can change things if you realize you want something different. You can change things on here just like you would in Excel by selecting things. You can also go up to this arrow and do an advanced edit to open up all those options again to get back into here. And then just click update if you do change anything. For example, I want to move and resize this little box. I want that to sort of fill my space that I'm using here. But that's about it. I was pretty happy. Now, you may have noticed already, as we were going along, that one of these data points doesn't seem to fit the other ones, and this is why we did a second measurement of the 0.4 molar concentration, because something seems to have gone awry with those data points. So you'll notice the average was minus 14%, and we go and look at the individual measurements, minus 14%, and one of them was minus 4%, and one of them was minus 24%, which is why I went ahead and remeasured it. And when I remeasured it, my first starting mass was 11.4, and when I was done after 45 minutes, I was down at 10.9. That's what I measured. Now, you'll notice the equation recalculated automatically. The average recalculated automatically. And because this cell is linked with this cell, this already updated itself. Now the other tricky part, the cool part, is that this data is connected with this graph, and the graph already moved this data point to where it belongs. And now we can see that we've got a line that makes much more sense. So we can probably be pretty sure that something happened with that data point. So we can go ahead and leave it out. I'm going to go ahead and leave it out. And you can also go ahead and just use this data point that I'm using here. 11.4 starting, 10.9 ending mass. So now I have my graph. I have my summary table. I can go ahead and copy this. I can do Control Copy and put that into my into Word or into my word processing. You could also, if you're interested, open this in a Google Doc, which is the word processing program that's also part of Google. Now, I'm just going to go ahead and try that. I'm going to copy this and go out to the home here. This is kind of the starting spot. And I want to go up to my main menu and I want to create a doc. A new blank one. And I'm just going to hit paste. Now it asks me right away, do you want to link this chart to the spreadsheet? And I do, I really do, because what that means is if I need to change something in my data or if I want to change how my chart looks, it's going to automatically update the chart that I have on my document that I'm typing in. So I'm going to go ahead and have that linked and I'm going to paste that right in. So what this means is if I were to go and change one of these data points in my spreadsheet, it would automatically update it in this file. So that's sort of everything you should need to know. If you have questions, feel free anytime. I would recommend that you do take the time to learn how to use these Google tools because especially when you're collaborating, when you're doing group work, having these files all living online and to be able to work on them at the same time makes a lot of things a lot easier. Okay. I hope that helps.